plot points A and B. We'll use our dividers and our triangles, and we're going to just jump right in. For this example, I gave you a mid-latitude and a mid-longitude. If I didn't give them to you, you would just pick out a mid-latitude and longitude that's somewhere near the positions that you're going to plot. So our mid-latitude here is 39 degrees north. This is our parallel of latitude, and it's in the middle. So hey, let's label this one 39 degrees north. North of what? It's north of the equator. And if you go more north, you get more north. So here is this 39. This is 40 degrees north. And 41 degrees north. And if you go south in the northern hemisphere, you get less north. So if this is 39, then this is 38 degrees north, and this down here is 37 degrees north. Our mid-longitude is 046 degrees west. This is the meridian in the center of our plotting sheet. Okay, so that's our mid-longitude. I have to draw all the other meridians, so that's what I will do next. I have two ways I could do this. I can enter in this scale down here with my mid-latitude of 39 degrees north, which is just shy of 40. Okay, it's only marked in 5-degree increments. So I don't know exactly where 39 degrees is, so I could just guess that it's right under 40. But there's a more accurate way of setting up a plotting sheet, and that's to take the mid-latitude and then come to the compass rose in the center, okay, and count up degrees of mid-latitude. So here we go, 10, 20, 30, 39. I'll mark that and count down 10, 20, 39. I'll hold that. And then I'm going to set up my triangle to draw just a straight vertical line. Make sure I take my time, make sure I line up here. This, so that I know this is totally straight. I've got my 39, I've got my 39. When I'm positive I'm straight, because it'll really negatively impact all of my plotting if it's not, then I draw the line. I'll do the same thing on the other side. 10, 20, 39 here. 10, 20, 39 here. I'll be 100% positive that I'm drawing a vertical line that lines up with 39, because this mid-latitude is 39. And when I'm positive it's going to be straight, I draw it. So if this is 46 degrees west, the more west we go, the more west we get. So this would be 047 degrees west. And this would be less west, so 045 degrees west. I think this is enough for us to work with here. But if we wanted to draw more meridians, we could use this distance that we know is 1 degree of longitude. And we could draw more meridians. This one would be 44 degrees west. 044 degrees west. The further we come out from the center, from the pre-drawn lines, we're going to assume that we get less and less accurate. We drew this meridian based off a meridian that we drew, okay? And so we can compound area very quickly as we get to the extremities of this, especially because this is such a small scale projection that we're developing. 1 nautical mile is tiny. This here is 60 nautical miles. Take that and compare it to what 60 nautical miles would look like on your regular training charts. It's very different. This is very small scale, so we're going to try to be as accurate as we possibly can, because our numbers have less potential for accuracy to begin with. Okay, so now that I have a latitude and I have a given latitude scale, right? Also a distance scale, because we know that 1 minute of latitude is 1 nautical mile. I need to develop my scale for longitude. I have degrees labeled, but what if I'm in between the degrees? How far in between? So I'll come down here, as we talked about a little bit earlier, and I'm going to enter in with 39, and then I'll use the line that I draw 39 as a reference for my longitude minutes. Here this says 0, this is 50, this is 10 more, so this distance is 60 minutes of longitude, which is 1 degree. The further we head to the poles on this Mercator projection, as we learned from lesson 4, the more tight they're going to get. Okay? So at the equator here, you have almost a perfect grid pattern where 1 degree of latitude is nearly equal to 1 degree of longitude, if not perfectly equal for our purposes. But as we get further and further north, that relationship changes and our grid is going to get tighter and tighter. All right, so I said that I could just guess where 39 is down here, but I have this really good information that I'm going to use, which is my 39 I drew here, high confidence on the fact that these both line up at 39 and that this is 1 degree of longitude. So if this is 1 degree of longitude, and I think it's going to be just shy of 40 on here to develop my scale. Let me line it up at 40. Okay. Yeah, it almost matches, a little bit too big, so I'll have to go a little bit under it. And then I want to make sure I'm always drawing straight lines. So that's one of the main things we do with our triangle. I'm going to line up this triangle with this 90 degrees on a line I drew. Hey, am I introducing error or what? Okay, and then I'm going to keep it straight and kind of move it, shift it down a little bit below the 40, wherever it lines up, so that this touches both sides, this side and this side. And then I will draw a single line and label it 39 degrees. And we're north, so I'll label it 39 degrees north. So from now on, when I try to scale my latitude, I'll be working off this line I drew. Okay, so this would be 50 minutes here. This would be 60 minutes here. And that's how I'm going to be able to plot my longitude. So let's just jump right in. 39 degrees for point A is latitude of 39 degrees, 26.1 minutes north. So 39 degrees more north than that by 26.1 minutes. That puts me somewhere here. For the scale that we're on, tenths of a minute aren't going to be accurately represented. So we will just do our best with the scale that we're on. We can definitely get to 26. I don't know about 26.1. That's asking a lot. All right, and then my longitude is 4552.4. So 4552.4, nearly at 46. I know I'm going to be somewhere in between here. Once I've identified where I'm in between, I'm going to work off this grid. It's the closest grid to that area. Okay, so 26.1 for my latitude. All right, that should be around there. And my longitude is 52.4. I could hold this triangle here. I could mark a reference point on my 45. Okay, and then dial up 52.4 on this line. Here's 50, right? That's 50. And then 2.4 is a little bit more. And I could start off of my 45, and that's where I am. But I already said that if I work off of a line that I drew, it's less accurate than a line that I didn't draw. So it would be more accurate if I worked off the 46 and worked backwards. This isn't necessary, but it is definitely an option to increase accuracy. You see I'm picking up the remaining distance in the degree and then working backwards here. You will get the same position, assuming that you drew everything else correct. If you don't understand what I just did, don't worry. Do it the normal way. We'll work on it. All right. So that is point A, and I'll label it waypoint A. Sure. We wouldn't ever label waypoints with letters, but we're just doing it for this purpose. Okay, point B, 37 degrees. So now we're going to be down here. Okay, 37 degrees, 54.2. So almost at 38 degrees. And then 046 degrees, 22.5. So a little bit over. So we'll be somewhere in here. So I'm going to work off this grid because it's the closest. My latitude comes first. 37, 54.2. This is 54.2. The 0.2 is a little bit difficult to get, but we'll do our best. And the longitude is 4622.5. So it'll be about a quarter of the way, a little further than a quarter of the way into here. How far will I be? To be sure, I use the 39-degree scale that I developed, but I'm reading the numbers off the bottom. So 22.5, here's my 20, there's my 2. I'm going to pick up a little more, that's 5. So 22.5 past 46. I line this up here. A lot of times I'm just using my triangles to draw straight lines. I'm using this 90-degree angle here, right? So I just line up this angle on this horizontal, and I know that this is vertical so that everything comes out tidy. And here I have waypoint B. Right, so now I've plotted 2 positions on there. All I have left to do is maybe get the distance between the 2. Sure, that could be a question. What's the distance? The easiest way in this case, because I can stretch my dividers out that far, is to stretch it out between those and then use my latitude scale, because I know latitude and distance the same on a Mercator projection. So this is 60 nautical miles because it's 60 minutes of latitude. That'd be 70, 80, 90, 96. So I have 96 nautical miles in between the 2 points. If I started on A and I wanted to steer to B, what would I have to steer to get there? What would our course be? I'm lining up my triangle so that this fine edge, not the writing edge, but the fine line that's parallel to it, directly lines up with the center of these 2 waypoints. And because I'm crossing a meridian while I'm doing it, let me do all 3 at the same time. So by all 3 at the same time, I mean that this line is crossing through both waypoint A and B, but this middle hash where all these stars on my triangle meet is on a meridian. And because that's on a meridian, I can read down or up a meridian depending on the location of my triangle. In this case, it's down. And I can read the degrees of this line off of the exterior notches on the triangle. So here I see 10 and 20. I'm pretty much right in between those, a little shy of in between, but I'll call it in between. So that would be 15 degrees. In this direction, the reciprocal of that, I use the red numbers, is 190 and 200, so that would be 195. I know it's 195 and not 15 because I know that north is 0, east is 90, south is 180, west is 270. So if I'm in this direction, I can't possibly be steering 015. It must be the reciprocal, which is 195. So from A to B is 195. From B to A is 015 degrees. True, because charts only speak the truth, and we have built our own chart here today. So that is how you set up a universal plotting sheet. That should be enough for you. However, if you'd like to keep going, I'm going to get into the southeast with our second example. I may move a little bit faster, but we'll see where we go from here. My mid-latitude in this example is 11 degrees south, and my mid-longitude is 140 degrees east. Okay, 11 degrees south. Because we get more south, this would be 12 degrees south. 13 degrees south. Less south would be 10 degrees south and 9 degrees south. mid-longitude